Hello everyone, this is Professor Hu. In this lecture, I will discuss Python basics. In this lecture, I will discuss Python language elements, Python input and output, Python control structures, Python functions, and Python classes and objects. Let's start from Python language elements. Computer science is the study of algorithms, and a computer program is created to implement an algorithm. A program is a set of operations on data to produce expected results. So we will focus on data and operations. Now let's start with data. Python programming language has a few built-in simple data types: number, boolean, and string. Number is used to store numeric value. Boolean is used to store true or false in making decisions on conditions, and string is used to store a sequence of characters. Language's built-in data types are available to declare data without programmers' work to construct them. Python number data type is used to store numeric values, including int, float, and complex. Python does not require to declare a variable's type before it is used. Once a variable is assigned a value, its type is determined by the value. Python has a built-in function type that is used to see the data type of a variable. For example, when variable a is assigned to 1, its data type is int. When it is assigned 12.3, its type automatically changes to float, the type for real numbers. And when it is assigned a string, its type is automatically changed to string, str. Int is used to store an integer. All these numbers are examples of integers. To see a variable's data type, use function type. For example, a is a variable that is assigned value 3. To see variable a's data type, use type a. Its data is displayed as class int, indicating its data type is int. Float is used to store floating point values. All these numbers are examples of float numbers that has a radix point or decimal point. What is a float number? Float number is short for floating point number, a representation of a real number in a way that its decimal point can float to support a trade-off between range and precision. This representation is more efficient than fixed point representation of a real number. Fixed point representation uses fixed number of bits to store the integral part, and fixed number of bits to store the decimal part, which is not as efficient as floating point representation. The example, variable y is assigned for 34.56. You can see its type using function type. And here display its type is a float. Complex is used to store complex numbers. A complex number has a real part and a virtual part. The part with j in a complex number is the virtual part of the complex number. All these following numbers are complex numbers. For example, variable m is assigned with 3 plus 4j. N equal to complex 23 plus 1j. L equal to complex 12 and 23. All these formats are complex number. And then when we use type, we can see their classes are complex. So in Python, we can use the three formats to assign a variable complex number. Boolean is used to store true or false in making decisions on conditions. String is used to store a sequence of characters, like hello world is a string literal. The string literal is enclosed in a pair of quotes, either single or double quotes. Python does not have a char data type. It considers string with one single character as a char data type. Like A is a string enclosed in double quotes, but can be viewed as a char. Similarly, we may use a function type to show the data type of a string, like in the example. Typecasting. Typecasting is also called type conversion or type coercion. It is a simple method to convert one number data type into another. There are two types of typecasting, implicit and explicit. Implicit typecasting is done by the interpreter automatically without the programmer's intervention. Conversion from a smaller type to bigger type is done by interpreter automatically and will be done implicitly. Typecasting from smaller type to bigger type is also called type promotion, like from int to float type. But the programmer can choose to use explicit typecasting. Type conversion from a smaller type to bigger type, though, can be done automatically by the interpreter, but the programmer can choose to use the inbuilt functions. From bigger type to a smaller type can be done by the programmers only to use Python predefined inbuilt functions like int, float, complex, bool, string, etc. Implicit typecasting. Obviously, my int is an integer, my float is a float. In addition, my int is automatically implicitly converted to float and being added with my float, and the result is float. The programmer can choose to use float by int to explicitly convert the type. Explicit typecasting. By default, integer myInt is implicitly converted to float, although you can choose to use explicit typecasting to convert it. However, if we want to convert the float to int, we must use function int to do the casting. When we want to convert a variable from a bigger type to a smaller type, we must use Python built-in functions to do the conversion, like from float to int. Python comments are kind of data placed in code to help the code reader to understand the code, or to prevent code being executed when testing code. Comments have no use for program code itself. Comments start with a pound sign. For example, in this short program code, the 3 lines start with pound sign are comments to help the code reader to understand the code. If they are removed, there is no bad effect to the code. As we said, a program is a set of operations on data to produce expected results. So we have discussed the data. Now we come to operations. Python has operators categorized in arithmetic, logic, comparison, bitwise, assignment, identity, and membership. We will discuss them in more detail. Python operators are basically used in the same way as we use in logic, mathematics, and other programming languages. Arithmetic operators are used to do arithmetic operations on numbers, include addition, subtraction, multiplication, division, modulus, floor division, and exponentiation. Logical operators are AND, or not. This table lists the operators and their rules. For AND, the rules are true and true is true, true and false is false, false and true is false, false and false is false. The rule for OR is true or true is true, true or false is true, false or true is true, false or false is false. The rule for NOT is not true is false, not false is true. This table lists the comparison operators used in Python, include equal, not equal, larger than, less than, larger than or equal to, less than or equal to. This table lists the bitwise operators used in Python. There are bitwise AND, bitwise OR, bitwise exclusive OR, bitwise NOT, bitwise zero field left shift, and bitwise signed right shift set. Ampersand symbol is for bitwise AND. Vertical bar symbol is for bitwise OR. Carry symbol is for exclusive OR, which get true when the two operands are different. False when they are the same. Tilde symbol is for bitwise NOT. Double less than symbols are for zero field left shift, which means shift bits to the left and fill in 0 from right entry. Double larger than symbols are for signed right shift, which means shift bits to right and fill in 1 from left entry. And the examples X and Y is operating on bitwise, bit by bit. X or Y also have operation on bits, bit by bit. And operation X exclusive or Y work on bit by bit. Not X work on bit by bit. Not Y work on bit by bit. 0 fill left shift according to the number in the right side of the symbol. And when we shift the bits to left, filling 0 from the right end. And lastly, the signed right shift when we shift the bits to right side, filling 1 at the left side. This table lists the assignment operators in Python, include equal sign means assignment, plus equal sign means plus assignment, minus equal sign is minus assignment, star equal sign is multiplication assignment, slash equal sign is division assignment, percentage equal sign is modulus assignment, double slash equal sign is floor division assignment, double star equal sign is exponentiation assignment, ampersand equal sign is bitwise AND assignment. Vertical bar equal sign is bitwise OR assignment. Carried equal sign is exclusive OR assignment. Double less than equal sign is left shift, bitwise left shift assignment. Double larger than equal sign is bitwise right shift assignment. This table lists the identity operators in Python. Identity operators include is and is not. Operator is true if the variables on either side of the operator point to the same object, or say both variables have the same value and are in the same memory location. It is false otherwise. In the example, X is a tuple and include car and truck. Y has the same value. However, they are declared as different variables. Now, we assign X to Z, so variable Z actually point to X and has the same value with X. So when we print X is Z, we'll get true because they have the same value and point to the same memory location. When we print X is Y, we'll get false because even though they have the same values, but they point to different memory location. Now for is not operator will be true if the variables on either side of the operator point to the same object. It will be false otherwise. In the example, X and Y have the same value, but at different memory location. We assign X to Z. Now print x is not z will get false because x is z. Their values and memory locations are the same, are equal. Now we print x is not y will get true because that's true that x is not y. They, even though they have the same value, but their memory locations are different. This table lists the membership operators in Python. The operators include in and not in. In will be true if a sequence with the specified value is present in the object. For the example, X has car and truck, and if we print car in X will get true because car is a value in X. Not in operator will get true if a sequence with the specified value is not present in the object. And for the example, X has a car and truck, print motor not in X will get true because there is no motor in X. Now this table shows the operator precedence in Python. Actually, they're about the same thing as in other programming languages and in mathematics when we use them. From this table, we can see that the exponentiation operator has the highest precedence, and the logic operator has the lowest precedence. Python expression. Any legal combination of symbols, such as labels, variables, constants, operators, and functions that represent a value is an expression in Python. An expression must have at least one operand. If only operators put together cannot be an operation. All these floated items. Now let's move on to Python input and output. Generally, a program needs input data and output results. Keyboard is input device, and monitor is output device. These are default input and output devices. And a program may also use file as input and output devices. We will discuss them in more detail. Keyboard is default input device. Python is function input or raw input in old version Python 2.7 to accept user's input. For example, function input is used to ask the user to enter username from the keyboard. The string, please enter your username, as the function input parameter is used to remind the user what to do. If you assign the input to a variable, you can show the content of the variable, that is the keyboard input by the user. Monitor is the default output device. Python uses function print to display output on the monitor. For example, function print is used to display a message in a string. Function print is also used to display content of a variable, for example, variable question. Further, function print can be used to print both strings and variables together, separated by commas, or connected by plus. In programs, files on disks can be used as either input, output, or both. Python has several functions for creating, reading, updating, and deleting files. In Python, how to open a file. Before a file can be used, it must be opened, and the program should indicate what to do with the file. Python uses function open to open a file. Use four modes to indicate how the opened file will be used. R means read. This is the default value. If no mode is pointed out, the file is open for reading. If the file does not exist, you will have an error. A means append. This mode indicates a file to be opened for appending content from the end of the file. If the file does not exist, a new file will be created. W means write. This mode indicates a file to be opened for writing from the beginning of the file. If the file does not exist, a new file will be created. X means create. This mode indicates to create a new file. If the file exists, you will have an error. In addition, the open file can be specified to be handled as binary or text mode. Text T means text. This is default. By default, the file will be processed in text mode. B means binary. This indicates a file to be processed in binary mode. Further, the open file can be specified to use line buffering or not. 0 means no buffering. 1 means line buffering is performed while accessing a file. How to open a file? Here is the syntax. The file object equal to function open, and the parameters include file name and optional access mode, buffering. Access mode and buffering are enclosed in the square bracket because they are optional. And there are three examples showing to open a file. The file name is sys214.txt. The first example is the simplest open statement. It simply opens the file name without access mode or buffering. The second, open the file with mode R means open to read, since it is default mode, so R can be omitted. The third, open the file. The file has a path to the file in the computer. But if the file is stored in the same folder with the program, we don't need to have the path. And R and T are default, so they can be omitted. So that means all the three examples are essentially the same. Every file has attributes. How to display an open file's attributes? Once a file is opened, its object attributes can be viewed, including file.name, that holds the file name, file.closed, that is true if file is closed, otherwise it will be false, file.mode, this holds the file access mode. For example, we open a file named sys214.txt. Then we can view its file name, status closed or not, and access mode, read or write or append or create. So the example shows us we can print out the file's name, closed status or not, or mode. How to read and open a file. Once a file is opened with read mode, its content can be read. File method read returns the whole text of the file, and function read with parameter number of characters returns number of characters. File method readLine returns one line of the file. For the example, when we use read function, we get the whole text of the file. How to write to an open file. Once a file is opened with write mode, it can be written. File method write with parameter string will write the parameter string into the file. For example, I open a file named my new file with write mode. Then I use method write with string. Python is a powerful and easy language. Then I can open the file and view it in Notepad. Yeah, surely I can use a read function to view the file, but I use another program to show it, and so that we can feel that we really write the code, write the string in a file, not just display on the screen. After an open file is used, it must be closed. How to close an open file? We use file method close to close the open file. Now let's move on to Python control structures that control the execution flow in a program. Python syntax support decisions and repetitions. Python's keyword if, elif, else are used in decision control structures. And keywords for and while are used in repetition control structures. Here, elif means else if. Python decision. Decisions are Python decision. Decisions are making choices based on conditions. Conditions are constructed with logical conditions and their combinations. For example, equals x equal to y, not equals x not equal to y, less than x less than y, less than or equal to x less than or equal to y, greater than x greater than y, greater than or equal to x greater than or equal to y. Combination will have more than one condition, like x larger than 2 and x smaller than 100. Another combination example, x equal to 3 or x equal to 9. So according to the combination and or and require both conditions be satisfied, and or require either one to be satisfied. Here is an example of if statement for Python decision. Please note, if condition ends with colon, if body statements must be indented, we can press spacebar or tab key to indent a line. To finish and exit if body, press enter key again. When condition is true, print inside if body is executed. When condition is false, printing inside the if body is not executed. This is an example of if statement with combined multiple conditions. Please note, logical operator AND is used to combine multiple conditions. And we may have examples use or and not and something to combine the multiple conditions. Same as many programming languages, Python evaluates 0 to false, non-zero to true. If statement body can have multiple statements as shown in the example. In Python, if statements can be nested. That means an if statement can contain other if statements. Here is an example of nested if statement. The if x larger than 0 and if less than 0 are nested in if x. Python decision may use if-else statement. If-else statement contains if block or if branch and else block and else branch. In either blocks, we can have some statements. When if condition is true, if block statements are executed. Otherwise, else block statements are executed. Like in the example, the left one shows if block is executed, and the right side shows the else block is executed. Also, nested if-else statement means if-else statement can be nested. One if-else statement may contain other if-else statements. Here is an example of nested if-else statement. If z is smaller than y and its else branch is one if-else statement enclosed in if x smaller than y with its else branch. So this is nested if-else statement. Python has elif keyword. Elif is short for else if. It is used to execute a continuous chain of the condition logical ladder. The syntax is if condition 1 is true, execute the statements in its block. And if elif condition is true, the statements in its box will be executed. And until the end is else, we may have statements to be executed. The example shows we get x value 5, x value 6. If x smaller than y, then print x is less than y. Else if x larger than y, print x is larger than y. Else, print x is equal to y. So this is an example shows elif statement. Repetition is a special kind of decision. When condition is true, the statements in a loop are executed repeatedly. Both while loop and for loop are supported in Python. With the while loop, we can execute statements in while body as long as the condition is true. Here is the syntax of while loop. While condition, then statements. And In the example, we can see n is 5, I is 0. While condition I is smaller than n, then execute the while body, print I, then increment I. So this will be a loop repeatedly execute to print I, and we can see the results. Keyword break can be used to break the while loop. Keyword break can be used to break the while loop prematurely before the condition becomes false. In this example, when I is 6 is larger than 5, the loop is broken. So we see that if there is no break, the loop will repeat to 10,000 times, but we break it out when I is larger than 5, so only printed the first 6 numbers. Keyword continue is used to skip executing an iteration of the while loop. In the example, we can see number 3 is skipped. We have if I equal to 3, then just increment I, but continue, so that we skipped the following statements in while loop. For loop can be used to iterate a set of statements once for each item of a sequence of collection. The sequence or collection could be range, tuple, list, set, dictionary, and string. Here is the syntax for loop. For item in iterable, then execute the statements. For and in are Python reserved keywords. This example shows that for loop traverses data in a range 5 to 10. This example shows the for loop with tuple. The for loop traverses elements in a tuple. This is an example of for loop with list. For loop traverses elements in a list. This is an example of for loop with set. For loop traverses elements in a set. This is an example of for loop with dictionary. For loop traverses key value pairs in a dictionary. This is an example of for loop with string. For loop traverses elements in a string. Break can be used in for loop to break the execution of for loop, just like in while loop. For example, in range 1, 5, number 2 and 5 modulus 3 equals 2. So at number 2, the loop was broken, and the following numbers are not printed. And similarly, keyword continue can be used inside for loop to skip the current execution cycle. And in this example, in range 1 and 5, number 2 and 5 modulo 3 equals to 2, so 5 and 2 were skipped. This example shows the for loop can be with else block, similar to else to if statement. The for loop may have an else branch to do something other than those inside the for loop. This example shows that in the else branch, print something like else block of for loop. And similarly, for loop can be nested. This example shows a for y loop is nested in for x loop. Now let's move on to Python functions. A function is a block of organized reusable code which runs only when it is called. Python provides many built-in functions like input, print, etc. Programmers can define their own functions, which are called user-defined functions. How to define a function? Here is the syntax in Python to define a function. Function definition contains the function head and function body. The function head contains ordered keyword def means define, then function name, then an optional parameter list enclosed in a pair of round parentheses, and finally colon, a colon to start its body. The function body contains ordered optional function docstring, that is the document string of the function. Then a group of statements that perform the function actions, and then statement return with optional expression to exit the function. And the example shows us the content of defining function print star, print string, and main function. The print string function has a parameter string. The main function does not have parameter. Both functions have the docstring. The docstrings are applied in documentation, not executed. Python supports arbitrary arguments. When the number of arguments cannot be determined, we can use a star at before the parameter name in the function definition. And then a tuple can be passed as arguments to the function. Arbitrary arguments are often shortened to *x in Python documentations. In this example, number of arguments is unknown, and in the function body, the third element of a tuple is to be printed. Python supports keyword arguments. The arguments can be sent with a key value syntax. The order of the arguments does not matter in this case. Look at the example. The order of arguments defined in the function is not the same as that in the calling. The order does not matter because the key is used. Its value is applied accordingly. Python also supports arbitrary keyword arguments. When the number of keyword arguments cannot be determined, double stars can be added before the parameter name in the function definition. Then a dictionary can be passed as arguments to the function. Parameters can have default value. Parameter default value is assigned at function definition. If the function is called without argument, the default value will be used. Just like in the example when we define function myHobby and with parameter hobby has default value tennis. And when we are executing the function and we can see the second time we have no parameter and tennis will be used. That is default value of parameter hobby. In Python, we can pass a list as an argument to a function. Any data type of arguments can be sent to a function, such as string, number, list, dictionary, etc. And it will be treated as the same data type inside the function. That is, if you send a list as an argument, it will still be a list when it reaches the function. In the example, a list, people list, is passed to the function list arg. It is processed as a list inside the function body. A function may return a value. To let a function return a value, use a return statement. Like in the example, we define a function fun return values, and we return the parameter in the function. Function definition cannot be empty, so if a function definition has no content, we can use pass statement to avoid an error. Recursion is a technique that can make a program lose context. A function calling itself is called recursion. Recursion may not terminate if it's not carefully written, and recursion may consume more memory and processor time. In the example, we define a function recursion fun, and we can see that inside the if branch, we assign the function itself with parameter k-1 to a result. So that means in the function recursion fun, we call the function itself recursion fun. And this technique is called recursion. Now let's move on to Python classes and objects. Basically two types of programming methodology. The traditional procedural analysis and programming view the system as a single object, while modern object-oriented analysis and programming view the system as a set of interacting objects. Traditionally, system analysis and programming methods are data-oriented and process-oriented. It views the system as one single object and focuses on data flow in the system from input through internal processes to output. Processes process data and pass on data to other processes by their values or by their references. Therefore, most of the time of a system analysis and programming is spent on figuring out data flow, designing databases, and designing functions and function calls. Modern system analysis and programming methods are object-oriented, which view the system as many interacting objects. Therefore, it focuses on objects and their interactions. Most of the time of system analysis and programming is spent on figuring out objects and their interactions in the system, designing object abstraction, that is the class, and their interactions by messaging. However, object-oriented methodology does not replace traditional methodology, because traditional methodology is still useful in designing objects' internal functions in the same way as previously for the whole system. Object-oriented methodology simplified analysis and design for large systems by dividing it into smaller subsystems. Now, let's focus on object-oriented methodology. In object-oriented methodology, the first step is to figure out objects and their interaction in a system. The next step is to figure out common features of the same classes of objects. For example, a school may have many students objects. Their common features will be described in a class of students. Objects are instances of a class, and the class is the abstraction of common features of the objects. So, the second step is to design classes of a system. Any object can be described from the data and actions. Therefore, a class consists of attributes which are data of their objects and called data members, and methods which are actions of their objects and are called function members. Python is an object-oriented programming language. How to create a class and to create an object? Here is the syntax for defining a class and the syntax for creating an object. A class definition consists of a class head and a class body. The class head starts with the keyword class, then the class name, and then a colon. Class body starts with an optional class documentation string, then the class suite. The class suite consists of all the component statements defining class members, data attributes, and functions, or methods. To create an object of a class, simply use an assignment statement as shown in the example. The example shows a simple class contains only one data member called attribute a equal to 20. It has no method. An object named obj1 is created from the class attribute class. Once an object is created, its member can be accessed using dot operator. In Python, all classes have a function called init, written in _init_, which is the first method in a class and is always executed when the class is being initiated. This method is special method and is called class constructor or initialization method. The init method is used to assign values to object attributes or called properties or other operations that are necessary to do when the object is being created. The first parameter of any method in Python class must be self. You may use other names, but it must be the first parameter. It is a reference to the current instance of the class, but is used to access variables that belongs to the class. In the example, an object P1 of the person class is created. The class name is used with parameters of its constructor, that is method init. Then we use the object to access the members name and age with dot operator. This is an example to define a class. This example defines a class employee. The class contains one data member, imp count, with initial value 0, and the constructor has three parameters, self, name, and salary. And it contains two other member functions, display count and display employee. Then two instance objects, imp1 and imp2 are created. The object can access its members, both data and methods, with dot operator dot. So this is about Python programming language basics. We discussed the language elements, input and output, its control structures, its functions, and classes and objects. Thanks for watching.